My name is Kaylee, my partner's name is Trey, and today we're going to be discussing the sublimation lab. So, sublimation is the direct phase change from solid to gas, and it's only possible to complete this process with some compounds, because many of the solids do not have an appreciable vapor pressure at easily accessible temperatures. And in sublimation, unlike boiling, like we've done before, it involves a solid's vapor pressure instead of a liquid's vapor pressure. So the most compounds that are capable of sublime, at their solid state, they have weak intermolecular forces. Some compounds that can be sublimed are camphor, benzophenone, naphthalene, anthracene, and pyrene, and their structures are right here. So some of the materials you'll need for this lab are a petri dish, a beaker, wire mesh, ice water, hot plate, mask, gloves, and goggles. And I'm going to hand it over to Trey, and he's going to discuss the procedures and the chemistry behind it. Thank you.
The procedure for running a sublimation begins with placing the sample at the bottom of the sublimation tube, lube all joints, apply the vacuum tube so that no sound should be heard, run the water through the condenser, use a Bunsen burner or any heat source in order to heat the sample, wait a few minutes for the sublimation to occur. If needed, you can scratch the surface to enforce the sublimation, remove the water source, and allow the sample to become room temperature, and continue to vacuum so that the sample can stay on the cold finger. The chemistry behind this lab is that sublimation is a direct phase change between solid and gas. The primary example of this phase change is carbon dioxide. When the gas goes from a solid, also known as dry ice, straight into a gas. This phase typically takes place when a certain compound's vapor pressure is equal to the atmospheric pressure or its applied pressure. Compounds that have the capability to sublime have a tendency to have weak intermolecular forces within its solid state, and some compounds also include symmetrical or spherical structures.